Good morning. All right. Yes, back to serialization. So it does appear as though into dB value, or the implementations, this one is never called. This one here is only ever called. So why is that? We have set dB page being called. Oh, let me check in. Sorry, just checking the calendar, see what my day's like. Trying to grab my water. There it is. Pour some hot water. While I do that, so it's this call here, the set call. Now, here we have a vector of u8s being passed into self.set as the value. Hot water is poured. All right. Set has a value, so it's generic argument. Value is just into dB value. Right? V, V, V here. Looks good, right? And for whatever reason, this one is not called, but this one is. I'm not sure why this one's winning. Is there a precedence? If we reversed it, that'd be strange. I didn't think. Still there. generic into db value generic. Xenocron, how are you, buddy? So this one is called, I don't know why this one is called O for this one, because the generic is just filtering, or it's generic for types that implement into db value. Apparently, db value is impuled for. I sound energized. Oh man, I, I don't want to think about my day yet. Um, energized in one sense, and I don't know. I feel like I'm pulled into two places at the moment. Okay, whoever this, I can deal with that later. This is my little kind of rest and recovery time. Okay, but it looks like this here into db value is impuled for vector view weights because vector view weights also has an implementation of serialize and db value. I did not think that I impuled db value for vector view weight. So that's Apple F12. Yeah, no, it's not impuled for vector. So why would that be? Why would I go to this one as opposed to this one? Oh, unless I'm looking at the wrong debug message. Let's get rid of some of these other pieces. Okay, these two I do want to see. Value generic. Oh, wait, did it do it here? It did. Okay, I was looking at the wrong one. Song is a bit distracting. I speak a bit of French and I can't do that right now. Okay. Just that one? Good. Okay. Now, the issue, if you remember, was that in our mutate test, we're getting a response here. Where's the response? Response here. Transaction result. Then down below somewhere. Oh, yes, here. We're asserting that these things are equal. We're getting the DB page key. And on the left, it's empty. On the right, we're expecting 4,096 bytes of nil. So this, let's just check. We did get a value back, but it's empty. DB page key looks correct. If we changed this just a little, like Shardo, right, we should get a different error. If we get the same thing, that's not good. Keys. Oh, well, the DB keys failed. Okay, I'll let that out for a moment. I want to see what comes back. So we did get a none right there. Okay, good. So we did get a query back, an answer, a response about the data in that page, but it's empty. The previous ones got the correct DB info, a checksum deserialized like magic. Why this one? Why is this one not working? Okay. Reset location. No, normally, where is it? Terminal there. And guess code paths is there. I want this to be there. Terminal, documentation, paths. Good. Exit archive get. You know what? I just clicked over here and I thought, oh, I wonder what it would say. we go. Let's see what happens. What did it say? Okay, I've examined that. Okay. Calls raw storage batch put. Really? I thought it was being called directly. Set database page batch put. Oh, no, no, no. It is. It is, isn't it? Set database page. Here. This set database page. Fascinating in that I'm actually using two futures instead of a batch put. I don't think it calls batch put. It calls raw storage to batch put. Where? Raw storage. Okay. Page data. Fine. Yes, we were staring at this. Okay. But some of this doesn't seem right. So where is batch put called? What is it? No, not that. This? Yeah, who's using this? Coverage. I don't think this is actually called at the moment. Not really interested in serializing a vector to postcard. Yeah, At the moment, it is using postcard. Yeah. Muted, definitely muted. Um, and I did, yeah, you missed my whole diatribe about sled being async, and excuse me, about sled not being async. It is not async. It is only async in my code in order to um, work in the test code because I don't want to spin up a TIKV cluster in order to test with, at least to unit test. Um, and then I went on to say, like, oh, this is so weird. Let's just dump the database. Yeah, it's just a mock storage thing. Yeah. Yeah. So the real interface is the TIKV interface, which is the distributed, key value data store. And because of how TIKV is set up, that really influenced the interface. And I tried to distill it down to what would work for both TIKV and SLED, um, but mostly TIKV. If I ever had to sacrifice performance or whatever, I tried to do so on the SLED side as opposed to the TIKV side. However, TIKV does require ownership of certain things, so there's copies in places. But, dumpdb, let's call that here. Do that. Oh, and I forgot to do an update. Okay. Looks like it's here. Key to value. All right, so what is the key we're looking for? I should have known. DB page data key. This should be the key that maps to the page of data. Transaction ID, page number, yes. BDB is really nice. Better alternative to SLED. But I am curious about SLED and those tools. So thank you for bringing this up. Copyright B trees. Oh, interesting. Fully ASCII compliant transactions. Huh. Interesting. He's working on a total redesign of it. Hmm. Save points on and rollbacks. Will it be API compatible or will that be ReDB 3? Ooh, Sled is kind of dead at the moment. He's working on a total redesign of it. Got it. Got it. Thank you. The current sled API is actually very similar to the TIKV API, which made it very easy to implement. And the behavior is very similar for doing range, which was nice. But I saw something just the other day. .rs. No, standard.rs. Oh, you imagine they're based on LMDB's API. Got it. Got it. Okay. I was surprised to see remove is being added to linked list. Like there are nightly. It's been nightly for years, sadly. Okay. Yeah. But the linked list type is very much a no one cares type of container in Rust. Oh, really? Interesting. Looks like the Rust version is pretty quick compared to some of these others. I had never heard of this one. Hmm. So by default, it doesn't need compaction? Is that because it spends more time doing writes? MDB has billion-dollar companies behind it. I'm just surprised at this here. Like where do they spend the time? Size after bench. Interesting. Okay. Oh, it can't compact. Got it. Okay. So it's just not a feature. Christopher Berner. Let's see. Dark magic. Astrophotography. Dark's processing program. Ooh, that's cool. User. Huh. All right. Back to the debugging. Well, thank you for that. I favorited ReDB. Actually, I didn't favorite on GitHub as well. Let's start that. Has a nice table API. Nice. That's nice. Thank you. Okay, it looks like this is a database page key. It's not this one. So this one here. 243, no, not one. 15. Oh, here. Yeah, here. So it does look like it actually has data. Okay. That's good to see. And just to verify the other ones don't match. Okay, they don't match. All right. So our quick little test here has revealed that we do have data. It is the right size, but our API to get it is returning something else. Oh, hold on. We're deserializing it. That's not what we want to do for this. So we get the raw, we get the value. So at this point, it's probably 4096 bytes. Then we call this. It says, hey, fine, it's nothing. So we return an empty array instead of having a deserialization error. That is strange to me. That's strange. It's for Sonic Kirja. It's more of a library for building things like SLUD or LMDB. Interesting. And above you said it was the backend for PJoule, distributed version control system. I've never played with darks. Who uses darks? PJoule as a tool is really advanced. Is it in docs? No. Huh. Fascinating. But the theory of patches is rather novel. That's interesting. All right, so what do I do with this? DB key type value. Because here the value, option to this value, the value type for this key is what? A database page key. This thing. I think I associate the values up at the top. Or is it? Yeah, vector of U8. Oh, so it's trying to deserialize it to that. Bah. Interesting. Jiu-Jitsu is superior because it's aimed at the working man. And it works on top of Git. Huh. Interesting. So I think this is incorrect. This line here. I have the song Delilah stuck in my head. It's been causing problems, so I went to the doctor and he said that I had Tom Jones syndrome. I told him I've never heard of it. And he said, that's not unusual. Oh, you know what? I don't have Discord open today. All right. Now, so I could make this work by doing the serialization correctly. Getting a Tom Jones song stuck in your head is very annoying. I don't know. It probably is. And I love Rust. That just being able to say, hey, this doesn't work there. Remove this trait from this thing, and all of these errors pop up. I really like that. I'm struggling with, you know, do I go for the ivory tower here, or do I just serialize, you know, these things into a database? I think I'd rather not serialize them. So let's go through the process. Okay. Archive dot raw storage dot was it dot get? Is it just get? That should work. And it should give us back what we're looking for raw storage to get. Pretty simple. Map get. What is V here? Oh, right. IVAC. Dash G. And then lint. Is it the E0277? Oh, interesting. File lint. Default. Just lint. See, what is the lint for this? Is it the whole thing? Oh, no. Possible values are lint. Got it. Okay. Dash G lint. Goodness. I feel. Wow, that is. It feels like this should be the default. I don't know. That just feels so useful. Okay. Anyhow, um, I can see a lot of them are kind of stacked up, which is fine. Dot raw storage. Dot get. Now in this case, we get a result option vector error. Oh, yeah. Now these two things are different, aren't they? db raw error and db error. Okay. Map error. Result is not a future. Oh, really? Does map error change? Oh, I didn't want to await it. Oh, do I have to set this up as async? Like so. Await it here. One of these things. It tries to do things in the same order as Clippy. Ah, okay. Couldn't convert dbr. Really? I thought that this doesn't set call put inspect error. It's just logging. Yeah, and it doesn't normally. Storage snafu. Got it. Very useful. All right, let's check the test again. And it worked. Okay. See, that's one way to do it. What's the other way? I could, instead of doing this here, I could have some other trait that the value type must implement where it deserializes itself. Okay. It's a possibility. Might fix that later. I'm glad we're going through this. Look, we've gone through these tests and actually found a bug. Very useful. Okay, which one's next? State key. db state key. Okay. db state key. Let's grab that. Needs to go before that. Okay, I've got db state key. And this should fail because db state new doesn't exist. Is deleted as false. Checksum. Wait, didn't I have db state up here? Database page. Commit record transaction. No, I guess not. Okay. Transaction ID. What kind is that? That's archive transaction ID. Page count 1. Page size 96. Checksum sum. This is the state of the database. And in this case, database page and db checksum is 1 to 0. Okay. And the last one. Transaction ID key. Does this just return a transaction? Yep. Transaction ID. It's one of these. Oh, it just has the page checksum. What was the page checksum? This. Okay, same thing. That's not great. Okay. Lovely. Okay, now let's change some of these. Let's say that this checksum is 9876543210. End checksum fine, don't care. Salts, they look random enough. Okay. Just want to be able to make sure that one of these checksums isn't bleeding into the other. Oh, fine. Just remove the 8. Or we remove the 9. These checksum mismatch. Expected this, found that. Interesting. That's funny. It is doing the. Okay. The end checksum of a single page of checksum. That's actually an interesting test. Just having that mismatch. Okay. We'll come back to the mismatches. But look at that. Some of the extra work that we did to send this back. That was nice. That was really nice. Okay. That all works. Good. Let's see. We have cargo, mock instant, cargo.lock. We need to remove the debug bits. Okay. Hang on. This one's fine. Okay, so what? Do unsaved files. Wait. Okay, this one. Ah, I forgot to save that. Okay. Anything else? Looks fine. No, that's gonna fail. Yeah, Cancel. All right. Well, that's good. That's good. Now, the reason we were doing that was so that we could have some tests ensure that our first implementation was correct. And we could improve it. So now that we have that, we also want to have a stream of data. So as this transaction is being recorded, we need to send the data on as well. Let's see how the request implementation plan. We have the stream, a collection of database keys that we've added. Request stream. We get a chunk. We have pages. And then we save. Now, I don't really want to. Okay. Kind of design decision piece here. Let's pull up the diagram. Watch your eyes. So looking at this system down here, data archive, this box here, will be storing data, right, persisting data to disk via the storage cluster, and streaming data via Iggy. Now, oops, this up a little. Oh, look at that. A little bit better. Okay. Okay. Do we want a streaming to only stream when something's been written to disk, or at about the same time, meaning that we only save data as fast as, or we only stream data as fast as we can save it. I would prefer, so one thing that I would like is for data to get to the readers as fast as possible, right? Even if that means having some sort of sponginess to the writes that are happening. I believe that these pieces over here on the right are just as good a place to store the data as this place here. And hmm, Because if the storage cluster fails, then we could reinitialize it with basically the data from the machine that had the most recent version, just up to date version. How you doing, Flask? How are you? Let's kick off all the tests while I look at this. All worked. I've got some. I think these are expected. I'll have to figure that out someday. Shared namestate exists when freeing it. Okay. Yeah. I haven't been on Twitch in a while. Last time you were here, I was just scratching the surface on Rust. Oh, wow. So it's been a long time. 2000s. Okay. Yeah, yeah, you've been following since February 2020. Sounds about right. Yeah. I can see your messages from November 6th in 2020. The last thing you said was 10-4. Wow. Wow, Twitch. Wow. Okay. So, how do I want to change this? I wanna bug the agent again. I think Amazon is training an LLM on Twitch chat. I wouldn't doubt it. Like everything, nothing but quality from exactly. It would be it would be an LLM. Yeah, yeah, you could absolutely. It'd be full of things like F and I need to log in. Just give me a sec. We're just doing some off-screen kind of changes here. What is that? Okay. You gotta go lurk. All right, nice you, dude. Happy Wednesday. Let's take a quick peek. I want to make sure that the mono draw is up to date. Let me give this a save. And then I'm going to commit this change. So I like this. What? I'm struggling with Git at the moment. Oh, good. There it goes. Lovely. Okay. Got everything cleaned up. Hey, Nate's. Would you be correct in reading that doc as the system is a single writer? Or is it a writer per shard, where shard is. Um, so per shard is the intention, and a shard is, I would say, an application at the moment, or a subsection of an application. Right? So imagine a website, you might have a forum be a shard, you might have the blog be a different shard, right? So you could subdivide it based on kind of concerns. You could also subdivide it on customers, so it could be like, uh, yeah, customer IDs, things like that. But eventually, I would like the ability to um, basically have it be a single writer, but have the machines that want to write register their intent. Oops, let's pull this back up. Similar to how SQLite in the Cloudflare environment works, but that's a ways off. It's quite a ways off. And being, yeah, I think in the case where, um, oh, what is this? Oh, oh, revert. Thank you. Save. Hmm, whatever. I was doing Git stuff. It must have detected that. Um, But I think single writer will get us pretty far. And the way I'm setting it up shouldn't slow down the writer. It should be very light. Okay. Now that I have everything committed, I wanted to play around with this stuff over here. Um, I don't know that I don't know. Okay. So we have record transaction. We have a transaction that comes in, which streams transaction chunks. Transaction chunks are, they have the shard, the database, transaction ID, pages, and a commit record. So these are the actual database changes, database pages that changed. I want to send those to the other machines. So process transaction stream. We could do this one of two ways. We could. Can you like fork a stream? Like I want two receivers. You can do it manually with a task, right? I thought there was something. Wasn't there? Tokyo. Let's see. LXRS Tokyo. No, Tokyo stream. I thought there was something that did fan out. I'm thinking of something else. Wrappers. It is just in Tokyo, isn't it? It's not Tokyo stream. It's in Tokyo. Fan out, etc. for syncs. See, I was thinking broadcast. Okay. Yeah, I think I said stream when I was thinking channel. Yeah. Tokyo doesn't really do much stream stuff. It just produces streams. Makes sense. Oh, it's there on nightly async iterator. Oh, that's nice. And I don't think this is exactly right either. Each cent value is seen by all consumers. Okay. Value is stored once inside the channel and cloned on demand for each receiver. Hmm. So if I want data to be sent through the system as fast as possible, there's quite a few different possibilities here. Essentially, could just drain it into some sort of the incoming stream into some Tokyo task that then drives the rest of this. But we definitely want to have some sort of response, right? Like if we had some sort of issue saving, we want to be able to say that. So for me, let's see. Oh, let's pull up the diagram. Mono draw. There it is. Storing to TIKV, I think, is really nice to have. Right? Um, this system here, the data archive system, is meant for having point in time DB recovery, right? To reduce the load on the writer, so the writer's not sending the data to all of the other readers. Right? So this acts as a fan out. If we, there we go, trying to just highlight something. If we got rid of this piece down here, right, um, there would be bootstrapping problems, but I think the system itself would be fine because I care more about the data on the machines than the data here, right? It's not saying that I don't care about it, but I favor the data on the machines themselves as opposed to the data in the cluster. So I would prefer to have data go through the system to the other machines faster and not have back pressure by the storage system. And currently, I have not added the streaming part. I, for whatever reason, added this portion first. So now I'm kind of rethinking things, but let's see. We could have the storage cluster feed off of Iggy. Basically, data comes in, goes into Iggy, and Iggy does the fan out to the storage cluster, to data archive, well, to rather the readers. Why do I not make an LDAP replica? LDAP is meant to be read a lot. A lightweight directory access protocol? I'm not sure I follow. Okay. Mm. Yeah. I presume that I could build an LDAP on top of this system. Right? Like the application could be some sort of LDAP server. Yeah. Well, I'm going to think about this for a minute. So, so another option, and so that's V5. Let's make sure all of these are in V5. Okay. What about this? Goals. Now these guys kind of sit outside of V5. Okay. Let's move those to the right. Let's copy the. Zoom out. I think it's time for yet another version of this. Okay. Duplicate. Just like that. Move this up. It's our new one. Also, for the task communication, how many tasks will there be? I'm not sure. I would expect that there's one data plane per machine. Um, so on the mutation side, coming into what we were just looking at, I wouldn't anticipate there to be many. Zoom in. Okay. Let's rename this to V6. So we could. Let's see, I'm going to move cluster management up for a minute. I'm just going to sit up there, cluster. Okay, move you down. This. And had something else. Not sure what to call it yet. If we had something come through here and go from there to here. So data archive would send to Iggy. Iggy would then do this. Interesting. Let's move those over. This could attach to the top there. There's something nice about this. No, 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 no. There's a situation where we need to be able to tell this guy to bugger off if they are in some sort of inconsistent state. The only way we're going to know that is if we are writing to the storage cluster. Okay, v6 gone. v5, come back, please. Okay, okay. Let's stick with this one. Oh, you're making a YAML serializer. Fun. Okay. No, we're going to stick with this. Okay. It's that moment of planning. It's good. It's good to do. So I think I definitely want to be able to give these sort of responses back. And Museum, you were saying that a vector of MPSC could probably be better performance-wise, depending on how costly it is for it to clone T. It's going to be 4 kilobyte vectors. It's going to be the largest data, right? So not so cheap. I mean, maybe we could toss them in an arc and then put them in the channels. They should be immutable, right? Broadcast channel clones on read. Vector of channels would clone on send. Interesting. What about that other pattern I did? Pushing the clone to send makes the read logic a lot simpler and faster. I see. Yeah. No, that's good. I like the idea. And in terms of having these transaction chunks, yes, you don't have to worry about lagging because each channel doesn't have to be synchronized. Interesting. Okay. The read's not being synchronized. You don't get eventual consistency. Yeah. Okay. With I like the idea of having the vector. I do think that most of the time the transactions are going to be small, right? And we'll be able to send 40 kilobytes really quick because I think we max out our chunks at 10 pages. And I think most of the time a page, these 10 pages would be fine. It is read only. A transaction chunk we will not change. Um, the pages will be copied, and the rest of it is rather small if it does need to be copied, or cloned, rather. I don't know if you saw the other day, but what was it? I set up a arc once cell. It's at least three heap allocation clones. Yeah. Oh, in the test code today. I don't know. It seems like an interesting pattern. Okay, I think that's the one I ended up using was the Tokyo one. Yes, because I used the new width, which isn't in standard. Is I mean, to me, it seems more correct if you want to enforce that something is immutable but shared, right? Instead of using a mutex or a read write lock. Weak one cell would probably be correct. Interesting. Standard has a work in progress. Exclusive type. Exclusive type. That sounds interesting. It's also getting a unique R. Interesting. Unique RC and maybe unique arc. Now, with weak, though, if there aren't any strong references, right, it ends up dropping the data, which I think is not what I want. I want it to live for as long as somebody's trying to use it. I just don't want them to mutate it. Oh, it's just behind the nightly flag, sure. It's only mutable access. Hmm. It allows exclusive to unconditionally implement sync. Interesting. Okay. It's based on the sync, the idea of the sync wrapper crate. The design has no API. Make it useless, harmless, and memory safe. Uh, I see. I think I was using one cell just to make it to have an alternative from Mutex. Basically a cow. Got it. But if my data isn't naturally send in sync, I couldn't just use an arc. I would need to use an arc and something else. A mutex, for example, right? And if I use a mutex, then oh, I see what you're saying. I could basically make it read only using a cow, but I'd still have to do a read lock on the mutex if I was using a mutex. This transaction chunk itself. Arc, arc acts as copy on write. You don't need a cow. The rest of them. Huh. So here, where was I doing the one cell bit? I want to understand this better. One cell not in coverage. Don't care about that. Keys, yes, here. That's right. It was in keys. This guy here. Now, the reason I did this was to avoid copying these vectors over and over and over again. Right? So, because of how, goodness, of how TIKV works, vector of UA is send and sync. Oh, I didn't realize that. I would want to know this. Because I know I've stuffed other things inside of a vector. Um, and that, of course, means that it's. Yep. So basically, if the type is send or sync, then it becomes send or sync. Oh, Beck isn't, but slice is. Wait. Hold on. I thought vector of U8s is send and sync. Oh, static, not vector. Okay, thank you. Got it. Oh, interesting. Actually, so you're saying that if I introduced a lifetime here, I could have an arc to a slice of U8s. I don't need a lifetime. Okay, let's dig into this if you have a minute. So let's say, or let's remove that. So we do this. A slice is like so, yeah? Okay, it works just like, really? Let's comment this out. So ArcU8 works like box of U8 does. I did not know that. Okay, this is interesting. Well, I don't need to know that. And like, but wait, isn't this an array? There's fundamentals doing back to arc. So what does this mean? Like, if I were to read this, this is an arc of a slice. It's a slice. There's no element like, huh, I follow. I follow. Okay. So in this case, we end up writing to a vector, and let's say this vector, instead of doing this, we say data dot, I guess, into box slice now. It's an unsized sliced. The arc gives it a size. Uh, Okay. So how do we take a vector into this? Okay, square brackets around t is a slice, and percent is a reference to a slice, which is commonly called a slice because it's the most common way of getting them, right? Arc from. Yeah, I tried to back into this. The trait. No way. Wow. I'm okay. That is neat. That is really cool. Well, I need to stare at that just a little bit more. Allocates a reference counted slice and moves V items into it. Got it. Yeah. Oh, that's nice. Huh. Into raw parts, vector. Okay. Safe allocate for slice. Copy non-overlapping. Okay. Oh, this is cool. Okay. Interesting that it ends up copying the pointer to the data instead of just reusing the memory. Is that because the basically you end up avoiding waste because you know exactly how much size you need. It has to copy it because of atomic ordering. Oh, I see. RC doesn't need to do that. I like that you know that without it being said here. I know if the Arc library from Servo is far more optimal at it. Got it. Man, today I learned. Wow. Okay. So in this case, targeting to have an arc of a slice, and let's say I'm just being, I don't know, annoying and wanting to avoid that allocation. You did mention that here we could collect into it. I imagine two arc slice. I wonder which is more efficient in this case. Um, takes each element in iterator and collects into an arc. You still have to do a memory allocation for this. Collecting arc is first done by collecting data into a vector. Okay. Back into box and then arc from box would be the most optimal way. Huh. Converts a vector into a box slice. Into box. Oh. Shrink to fit. It looks like it. Okay. No global out of memory hand. Okay. What? It looks like it might still allocate here. Oh, I see. That's for the upcoming stuff. And interesting. I don't see any other reference in here. Scroll up, allocate. But it's calling this function, yes? Arc has two blocks in it. Okay. Control block and a data block. Okay. Control blocks so the ref counts. Makes sense. Okay, for layout. Drop slow. Oh. Okay. The second allocation probably has to be aligned properly with the main one, which is why it has to reallocate in the arc inner there. Oh, oh, I see. Where is the implementation of this? It's kind of expecting it to be in this file, but it's only here, and this is for the Linux variant that you mentioned. Is it one of those mysterious compiler functions? That's not the Linux variant. Okay, that's fine. Uh, did I read that backwards? Not. Oh, not. Okay, so this is the implementation I was looking for. Okay. I. All right. So coming back to the code, code. We have this here. Arc from that. This is probably just fine as it is. So given the second close the allocation, but you mentioned it's more efficient than a one cell. Oh, that works for me. I didn't even know this existed, so I'm glad we did this today. Thank you for mentioning this. Now, in where are other places somebody might use something like this, right? Like for me, I'm passing basically U8s around, and they just need to be read by multiple things. So it's nice to have a copy. I don't know if a smart pointer can use DST. I don't know. Oh, when you see T may be sized. Okay. Coming back, I want to see this one more time. Here. Oh, interesting. Yeah, I've seen Arcster and Boxster. Arcster is like T, but UTF-8, yeah. I don't remember where I've seen it. It's not that common though to see Arcster or Boxster. I think Boxster, I think I've seen more. Oh, you know what? I think we've talked about Boxster before. I've seen Cow, of course, yes. Yes, a bunch. Yeah, that's interesting. I wonder what other DSTs would be useful in something like that. Can you do a cow? Because that's veckish type as a cow. Yes, okay. That's neat. That is cool. Okay. Um, okay. Oh, that's clever. It's B. Cow is weird. That's what do cows say? Cows say boo. Um, yeah. Yeah, why is it B? Um, oh, that's really useful. Okay, so basically slice, that's primitive type here. What else is it's interesting here because I mean we happen to know it's a DST, but it doesn't actually say. Yeah, I'm just wondering what so there's stir, um, right? Basically a slice, right? Not a range, a slice. Um, the first wait, what? Oh, thank you. Dynamically sized view of can do. Thank you. Stir. First line also. Okay, yeah. To me, these are all like the reference types, right? The path for pathbuf, C stir for C string, stir for string, OS stir for OS string. Dyn trait though, that one's interesting. Can you do arc dyn trait, right? That clonable and shared. So if you had some sort of implementation that had interior mutability, you could just pass that around. Um, that's interesting. Or you could just have it as read only. That is pretty neat. Or arc mutex info, of course, yeah. Wow. Wow, wow. 5 years in. Here we go. And this is good. Next, you'll teach me about how DST works. I've got 20 minutes. Um, next stream. That's fine. TLDR is that it has to be the last field. Ah, yes, okay. What if you have two? This field is basically, or whatever memory follows. Yeah. Okay, that makes sense. Huh, fascinating. That is fascinating. Okay. Can you make a slice into an arcty? I was just thinking about that. This line here is 618 because you don't own the data, right? This is a reference. So you would need to actually pass ownership into the arc. I don't think you can because of ownership. Right? You need to be able to push the memory into this. So, like in this case, what we're doing here is allocating in order to be able to put it in there. The answer can be found with, okay, we're on a hunt. Arc from, arc in, try from. It does allocate on its own, but then it also deallocates. Oh, wait, this is from an array. That's not what I want. Try from. We have a try from, which is a boxed, okay, try from. Box slice. Here. That's also not what I wanted. It was arc from here. So yes, where t is clonable from slice. Interesting. Okay, yeah. Sampling scale. That's pretty neat. Arc from slice. What was it that was called though? From slice. Okay, makes sense. So they're casting the T. Yeah. Okay. That's neat. That's neat. Yeah. I did see that, but I've been, like, this is the first time I've ever seen it. Here's clone, here's copy, and here's another clone for the same thing. No, that's something else. It's called specialization, and is your number one wanted feature. Oh, interesting. So this isn't available in standard, well, in stable Rust. Oh, wow. Okay. That probably never will be. Oh, wow. Morning, range bomber. Oh, it's a big Pandora's box if users could do it with regard to trait resolution and orphan rules. Hmm. Well, this has been a fantastic learning session today. Not satisfied. Weren't we just looking at that? Arc from T, where T is clone. Pretty sure U8s are clonable. Unless DB key needs something. Oh, DB key. Here we go. We need to borrow here. Guess only for B. Ah, I can't move. Yes, 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 of course. Format. Okay. Okay. Now that works. Well, that's a really great learning today. Yeah, very productive day today. Um, this I am going to overuse in the future. This is amazing. Also, box. Well, that's interesting. Okay. Uh, so, so given that this is read only, right? Let's say you only had one type or one instance. Could you still get? Looks like you could get this as long as there wasn't any strong reference to it. Now, does that mean we could go back to a string at some point? Because T here would be just like what does this mean when we have arc of this, right? Where data is a slice. So we have this. I gotta go to Rust Playground. Syndrome. I have no idea what that is. Apparently, I started. Oh, wait. Yeah, I think I remember. Why is that not favorited? Favorite? Mm, yeah, it's close. It's Rust stuff. Arc from, let's just say, real world, right? Let foo equals that. What does foo dot to inner give us? What is bar at this point? Right? Will this compile? Oh, standard. Is it sync arc or is it standard arc? We were just looking at the documentation. Standard sync arc. Let's first the okay. Command enter. Command enter. There we go. Type annotations needed. Say arc stir. Into an R4 arc stir. Interesting. Is that because into inner is only implemented for certain T's? Oh, no. Okay, it's just written differently. Okay. So it's arc into inner. You pass foo in. There we go again, saving. Type of stir can't be known as a compile time. Okay, lovely. Required by the call to this. That's cool. T double. That impl T doesn't say size. Here I keep tabbing to the wrong spot. On this, I was looking for T. Like, where is T? What was it? Control command minus? No. How do we collapse everything again? It's minus. There we go. Okay, here. And this is in which group? Ah, yes. That's it. Okay. Oh, wait, that's not into inner. Where did into inner go? Yeah. Okay. Well, that's perfect. That's just what I wanted to know. So I wonder on something like vec, does it have the reciprocal like from arc, like a try from? Because of course it can fail. Try from. I guess it would be arc vec. No, arc to vec. Oh, interesting. Oh, got it via the deref. Yeah, which does another allocation. Okay, just wrapping my head around it. It's fun. I don't know. It's how I learn. Like you get a new toy and you poke all the buttons, and that helps me cement it into my mind, and make it a little stickier. That's neat. Okay. The allocation may get optimized out. So the deref would. Where would the code for that optimization be? Right. I guess some specialization there. Oh, it would be in the smear or a there. Got it. I see. Well, this has been fun, and we made improved it again. Very nice. Well, I feel like I'm holding you up from your lunch, Museum. I should probably get going as well. Okay, that all looks good. Oh, wow, that's hot. Okay. Ooh, I just poured some hot water and then drank it. Well, y'all, thank you for hanging out. I'm going to get ready for a meeting. Looks like a gorgeous day out. Hope you'll have a wonderful day. Happy Wednesday. We shall raid. Tom today. There we go. Take care. Bye bye.